Uh, Today, let us discuss regarding chapter by name solutions, which is there in your second year syllabus. Okay, so in the earlier classes, I think you people would have gone through some chapters which we had started like kinetics, haloalkanes, and haloarenes. Again, we'll be just continuing with the next chapter by name solutions. Okay, so in the final exam part, I mean to say in the theory exam, you will be getting say around 8 marks from this chapter. Okay, it is one of the easiest chapter. Try to understand few concepts. I think it should be easier to remember everything. So nothing to worry regarding it. So if you're going to the NEET and the JEE exams, I think you will be getting questions on these chapters also. So just going through this chapter by name solutions. So let us start it. Okay, can you people think about a solution? We can just define, how do we define a solution? We can define solution as solution is a homogeneous mixture of two or more components. So it is a homogeneous mixture of what? Two or more components. Okay, so let us come to this a bit later. I mean to say, I'll try to give you an example regarding this. So a solution means, I told, a homogeneous mixture of two or more components. Homogeneous, it indicates. So let us consider a beaker containing water or a glass containing water. To that, let us add some amount of salt. To that, we can add sugar. What will happen? So once we add the salt and the sugar, automatically they both will dissolve in the water. So that the salt and the sugar that has been added, they will be uniformly distributed throughout the water or the solvent that you have taken. Hence, that uniform distribution is called as a homogeneous mixture. So we can call it as what? It is solution is a homogeneous mixture of two or more components. Okay. So now going forward with this one, let us start with, tell me what is meant by binary solution. So as you people might have heard in the other chapters, we come across say like mono, bi, di, tri, tetra, like that, many sort of words. So here also we can just go through. Here we are given like bi. What does bi indicate? Bi indicates two. Okay. Binary solution again. What is the binary solution? It is a homogeneous mixture of two components. Okay. Homogeneous mixture of two components is called as the binary solution. Okay. Now let us consider. Let us consider this is a beaker containing water. To this, let us add one spoon of salt. Okay, so till now, I think if you people have observed, I have started introducing a term called as component in both the cases. Homogeneous mixture of two or more components. I told binary solution means it is a homogeneous mixture of two components. So bi means Two I told. So two components. Two components means it's just like nothing but solution means you come across like solution is we have added 1 spoon of salt, that is one component. We have taken water, that is one component. So this one is water that we have taken. So can we say these two are the two components? One is salt and the other one is the water. So salt and water are the two components. The component that is present in smaller amount. The component that is present in smaller amount is called as the solute. What is that? The component present in the smaller amount is called as solute, and the component that is present in the larger amount is called as what? The solvent. So the component present in smaller amount is the solute, the component present in the larger amount is called the solvent. So solute plus solvent, this gives rise to a solution. Okay, solute plus solvent gives rise to solution. So what are the things that we have added over here? We have added in this example that we have taken, the solute that we have added is salt. The solvent that we have taken is water. So we got a solution. How many components are there? There are two components. One is salt, the other one is water. The component present in smaller amount. The component present in smaller amount is called as the solute. The component that is present in larger amount is called as the solvent. Is this one fine? So another one property that you come across over here is generally the solute that we have taken, solute changes its physical property. So when the solute is added to a solvent, it changes its physical property. So or the physical state you can say. So solute changes its physical state. So it's just like example like you can take salt we have taken. Salt before adding, let us consider 1 spoon of salt that we have taken in the spoon. If you observe the salt, it will be in the solid form. As soon as you add it into water and stir it, what will happen? The salt dissolves in the water and it just gets dissolved in the solvent. So you won't be getting the salt. Again, I mean to say the solute that you have taken, it was earlier in the solid state, it got changed to aqueous form. So solute changes its physical state. Same way, if you go to solvent, it does not change its physical state. Okay, solvent does not change its physical state. Solute changes its physical state. Because water you have taken earlier, after adding salt, again it will be water only. If the solution form remains the same, again I think there won't be much of a change. So salt would have been solid when dissolved in water, it got converted to solution form. Water you have taken anyway, it will be in liquid state only. I think as soon as you add salt, I think there won't be any change. So it results in the formation of solution, but the physical state remains the same. So binary solution means what? Homogeneous mixture of two or more components. So in this chapter, you have to many number of times I will be using this term called as solute and solvent. So what I will do is, you people have tried to remember it now only. I will be indicating solvent. I will be indicating solvent with the prefix 1, and I will be indicating the solute with the prefix 2. Okay. So while I am talking regarding that, once we start writing the formula, I will get to know. Solvent is, generally if we write 1, we will be showing it as solvent, or 2 means we will be indicating it as solute. Okay. So now, If you are fine with this one, anyway, you people have to be fine. So we'll move to the next part. So the other thing that we come across over here is, once we are done with this one, you people should understand where do you find this importance of these solutions? Where in the general day-to-day life, where do you come across these solutions? So let me give you one example. I mean to say, what is the thing that you come across in your daily life? Let us just try to analyze one thing like that. For that, if you people remember, in the earlier days, say around 10 to 15 years back, if you assume, I think there will be a lot of, I mean, in the summer time and all, we could have seen in front of our house ice cream wala who used to come with a dabba full of ice creams or the kulfi ice creams. Okay, so anyway, that person didn't have the fridge, so he used to come in front of the house pushing the vehicle, meant to say the whatever the vehicle that he had got, but the ice cream that was given from him was also again in normal state only. I mean to say, it was not like in the hot sun, if you take the ice, what will happen? Automatically it will melt. So, but even if he comes, but when he is coming also after purchasing the ice cream, I think it will be in the normal state. What he would have done to maintain that state? If you can imagine, whatever that ice or the kulfi ice creams, whatever we eat, we were eating, they were kept in a container which is surrounded with ice. Okay. Normally, the freezing point of water is what? 0 degrees Celsius. So, in the summer, what will happen? Automatically, if the temperature, because of the temperature, it can melt easily. So, even if you slightly be careful or imagine, so normally the first time if we just take ice cream and after eating it, you may find some small amount of salty nature. Like it will be small salt nature will be like. If you just eat it, I think you will feel the salt nature. That is just because the ice cubes that have been covered, to that we add salt. The ice cubes which has been covered. So for that ice cubes, what they do? They add salt. So if they add salt, what happens? Normally the freezing point is 0 degrees. If you add salt, this freezing point still goes down. So it will be say around somewhere around -2 degree, -3 degree like that. So this point will be studying with respect to solution by heading called as depression in freezing point. Similarly, if you consider another one example, if you consider, say, in the earlier, say around 10 to 15, 10 years back only, let us consider, even now also it's fine. If you are going in your car, what will happen after, say, traveling around 50 to 60 kilometers, if you observe, the outside bonnet will be a bit hot. Okay, so how will that be cooled down? That will be cooled due to the presence of a coolant which is present in the automobile. So, provided if the coolant is not present, what will happen? We won't be able to sit in the automobile only, because normally whatever in the earlier cases it was just like, so vehicle is totally hot, what you have to do? We have to add some amount of water. So to that water, what we were doing, to the coolant, whatever we are adding, to that coolant we used to add certain amount of electrolyte. Normally the boiling point of water is 100. We just try to elevate the boiling point of water, say around 105 degrees Celsius. So by adding certain electrolytes, the boiling point is increased to 105 or 104 degrees Celsius. So here, in the normal case, the boiling point will be in the automobile, it will be around 100 degrees. If this gets increased to 105 degrees, somehow the temperature can be maintained. So that again we'll be studying in detail when we move to a topic called as elevation in boiling point. So few of these things we will be studying in the coming classes. So now, as I told you, let us come back to this point only. Let us come back. Solutions we told, binary solution. As soon as I talk regarding something called as solution, you people shouldn't assume that a solution means it is a liquid. Solution means it is a liquid, you people should not assume. Okay, so this solution can be classified into many types, which we'll be studying under the heading called as types of solution. Okay, types of solution we call. So it's just like there are about 9 different types of solution. We come across what? 9 different types of solution. So a different combination based on the physical states. Okay, so on the starting in the general case, we can just classify the solutions into 3 types: as solid solution, liquid solution, and gaseous solution. What is meant by a solid solution means a solid solution is a solution in which the solvent is solid. What is that? A solid solution is a solution in which the solvent is solid, but the solute can be solid, liquid, or gas. Okay? So, similarly, what is a liquid solution? A liquid solution is a solution in which the solvent is liquid, the solute can be solid, liquid, or gas. Similarly, what is a gaseous solution? A gaseous solution is a solution in which the solvent is gas, the solute can be solid, liquid, or gas. Okay, so we have to now start with what is meant by types of solution. Okay, so let us continue with this types of solution. So as I told, the solution can be classified into how many types? The solution can be classified into 3 types as solid solution. So what is a solid solution? I told solid solution is a solution in which you just write it like this so that it will be easy for you. Okay, I'll just make 2 classify it as solute and solvent. Let me write solid solution is a solution in which the solvent will be what? Solvent will be solid. The solute can be solid, liquid, or gas. So in all these cases, what will happen? The solvent will be solid. Okay, so solid solution is a solution in which the solvent is solid, but the solute can be what? Solid, liquid, or gas. Okay, so similarly, what is meant by a liquid solution? A liquid solution means what? Again, a liquid solution is a solution in which the solvent will be liquid and the solute can be solid, liquid, or gas. Again, the same case. In 3 cases also, it will be liquid, liquid, liquid. Okay, same way. How about gaseous solution? Gaseous solution means the solvent will be gas, and this can be solid, liquid, or gas. Okay, so we can just classify it this way. So let me just make a column. It doesn't look good. Okay. So let's just try to erase a bit. Okay. So three different types of solutions. Okay. One is solid solution. The other one is liquid solution. The other one is gaseous solution. I think hope it should be clear by now. So a solid solution means it is a solution in which the solid is the solvent and the solute can be solid, liquid or gas. Can you people think about an example for solid solution in which the solute is solid and the solvent is solid? So you can consider the example copper in gold. You can consider the example what? Copper in gold. Okay, copper is also solid, then gold is also solid. So that is an example. Similarly, can you think about an example for liquid in solid? For liquid in solid it is, you can consider amalgam in sodium. You can consider NaHg. Okay, so amalgam in sodium. That is an example. Amalgam is again that, so mercury is liquid, sodium is solid. Similarly, can you consider, give an example for gas in solid? Gas in solid means you can consider hydrogen in nickel. Hydrogen on nickel, or in other words, you can also call it as occlusion. Okay, so these three are the examples for, say, solid solution. Okay, three examples for what? Solid solution. Same way. Now, if you go to the next part is what? Liquid solution. Liquid solution means here the solvents will be liquid, the solute will be solid, liquid or gas. So give an example for a solution in which the solute is solid and solvent is liquid, means it's one of the simplest examples you can consider. Glucose in water. Glucose is solid and liquid anyway it is water. Give an example for another one. Liquid in liquid it is, you can consider ethanol in water. Okay, ethanol in water is another example for liquid in liquid. Give an example for another example for gas in liquid. Gas in liquid is, you can consider oxygen in water. Oxygen in water is an example for gas in liquid. Okay. So now, so what is the next one which is left over? The leftover is gaseous solution. What is a gaseous solution? A gaseous solution is a solution in which the gas is the solvent and the solute is solid, liquid or gas. You can consider for gaseous solution, solid in gas, you can consider camphor in nitrogen. Camphor in nitrogen. Similarly, can you people think about an example for liquid in gas? Liquid in gas, you can consider water drops in air. Water drops in air is an example. Same with gas in gas, you can consider any example, oxygen and nitrogen. Yes, fine. So you can see I told us that point of time I told you people there will be 9 examples I told. So I think 9 different types based on their physical state. You can just go through here. So here you can just consider what type of solution. This one is solute, solvent, and examples. Fine. So three types of solution, namely solid solution, liquid solution, and gaseous solution. So people have to remember this. Solute means the one which is present in smaller amount. Solvent means the one which is present in larger amount. So if solid becomes the solvent, the solute can be solid, liquid, or gas. If the solvent is liquid, the solute can be solid, liquid, or gas. Similarly, in gaseous solution, if solvent is gas, the solute can be solid, liquid, or gas. Few examples for this one. I think you can go through in the textbook also few more examples if you get. I think it's not an issue to go through. Okay. In the last class, we had studied regarding what is meant by a solution. What are the different types of components that you come across in solution, namely a solute and solvent. And we again studied, we tried to classify the solutions. We try to classify the solutions into 3 types, namely solid solution, liquid solution, and gaseous solution. Okay, so and based on the different types of combinations on the what is the solvent that you are taking, we could see about 9 different types of solutions with the examples we have studied in the last class. Okay, so today let us go to the next topic by name concentration of the solutions. This concentration of solution is very much important in the coming classes. Anyway, you people might have studied this one in the first year PUC, but a brief introduction regarding the different types of concentration of the solution, how we will be expressing that we will be studying. First of all, what is meant by concentration of a solution means? Concentration of a solution is the amount of solute that is present in a given amount of solvent. What is meant by concentration of the solution? Concentration means it is defined as the amount of solute that is present in a given amount of solvent. Okay, so to make it very much easier for you people, let us try to understand this concept in a different way. So let us consider we are taking a glass of water. Let us consider this is a beaker which is containing water. A beaker containing water. Okay, this is water. Okay, so water, in other words, this one is solid. Okay, now to this, let me add sugar or salt, anything which can be easily dissolved. Okay, so if I add 1 spoon of sugar to this solvent, what will happen? The sugar will dissolve. Similarly, I'll add another 1 spoon of sugar. What will happen? Again, that sugar also will dissolve. I'll add another 1 spoon, 3 spoon, 4 spoon. At some point of time, what happens? The solution will become saturated. We'll come to the saturated part a bit later. So the solution, what is happening to this water or the solvent that you have taken? With the addition of more amount of sugar, the sweetness is going on increasing. So each and everybody everywhere. We can't just go and taste the solution and try to find out what is whether it is sweet or sour or it is salty, because we are dealing with chemicals and we can't do that. Okay, so we try to express as the amount of solute is increasing. Amount of solute is increasing in solvent. What is happening? The solution is becoming more and more concentrated. This concentrated, I am telling, this concentrated is nothing but the solute, more amount of solute is getting dissolved in the solvent. So how can I express this concentration? This concentration of a solution, it can be expressed in many ways, which that all I told in the earlier class, in the previous class we had studied. So concentration of a solution can be expressed in many ways, like one is by name mass percentage, another by name volume percentage, another one by name mass by volume percentage. Then you come across something called as molarity, which is denoted as capital M. Then you study another concept called as molarity, which is indicated by small m. And then again you come across another concept called as mole fraction, which is indicated by x. So again, still there are many more like ppm. You come across formality. But once, if we are using those when we are doing any problems, if we come across, I'll let you know people. So right now in the initial case, I think these much are enough. Mass percentage, volume percentage, mass by volume percentage, molarity, and mole fraction. So these all concepts should be, you people should be thorough. Now, can you please let us try to understand what is meant by mass percentage. So what is meant by mass percentage means, again this is also, let me consider, I'll take say around 10 grams of sugar, I'll dissolve it in 100 grams of water. Okay, I'll take 10 grams of water, dissolve it in 100 grams of water. So I have to find out the mass percentage means, so it is the mass of the solute that you have taken. The component, what is the component? Sugar is the component. Sugar is the solute, sorry. Sugar is the solute. And what is the total mass of the solution that has been obtained? Which is 110 into 100. So, once we do the problem, you will get to know. So, mass percentage is given by mass percentage is equal to mass of the component divided by total mass of solution into 100. So this is one way of expressing. Okay. So mass percentage is what? Mass of the component divided by total mass of the solution into 100. So preferably you can take the component, you can take it as what? Solute. Okay. So what I told you people is, if you are considering an example, say calculate the mass percentage of a solution obtained by mixing 2 grams of solute in 10 gram of water. Okay, you people have to find out the mass percentage of this one. So you can just write it as what mass percentage is equal to what is the mass of the component, that is the mass of the solute that you people have got is what? 2 grams. So it is 2 divided by total mass of the solution. You have dissolved 2 grams of solute in 10 grams. 2 plus 10 is how much? 12. It is into 100. So you can say 2 divided by 12 into 100. Okay, so 2 divided by 12 means it will be say around 1 by 6. 1 by 6 or 100 divided by 6. So you can just cancel it out. 6 ones are 6, 4, 6 6 are 36. It goes on. 16.66%. So the mass percentage is how much? 16.6%. So this is one way of expressing mass percentage. People should remember the mass of the component I told it is solute. The solute can be expressed in grams or kilograms. Same way, total mass of the solution. Total mass of the solution that can also be expressed in grams or kilograms. Preferably, let us take it as grams. Since they have given it in grams, we will try to express it in grams. Is that fine, children? So this one is mass by mass percentage. Okay. So how can I represent this? Can also be represented as what? W by W percent. Both are mass only. Mass by mass or mass percentage we people can represent. The other one is, which we will be studying is, what is meant by volume percentage. Okay. So as we have discussed there, so here it was say mass percentage we represented as W by W. We can just represent this one as E by V. Okay. Both will be volume. So volume percentage is defined as what? Volume percentage is defined as the ratio of mass of the solute. This can be either in ml or liter. You people have to be careful. In the mass percentage, it was mass of the component. It is expressed either in grams or kilograms. In the case of volume percentage, the mass of the solute will be in ml or liter, divided by the total volume of the solution. Okay, so we can just represent it as what? So, volume percentage is equal to volume of the solute. It can be in ml or liter, divided by total volume of solution into 100. Okay, again this one also will be in what? ml or liter. They are expressed in what? ml or liter. Is this one fine? So mass percentage is mass of the component, that is the solute, divided by total mass of the solution into 100. What is volume percentage? Volume of the solute in ml or liter divided by total volume of the solution. So we can just go through a problem for this one. Problem is, say, calculate the volume percentage of solution obtained by dissolving 30 ml of ethanol in 90 ml of water. Okay. So I think you people will be knowing the formula. We can directly just apply the formula. Okay. So the formula will be what? Volume percentage is equal to, you people can see it, volume of the solute in ml of liter. So which is the solute that is present over here? The component that is present in smaller amount. You are having 30 ml of ethanol and 90 ml of water. So 30 ml of ethanol, that becomes the solute. So volume of the solute, so that will be 30. Anyway, we have written it in ml only. 30 divided by, what is the other thing? Total volume of the solution. Total volume means 30 plus 90. 30 plus 90 will be how much? It will be 120. So 30 plus 90 into 100. So if you just simplify, you will be getting 30 divided by 120 into 100. So we can just cancel it out. 34 so 4 this gets cancelled 25 times. So what is the percentage? Volume percentage will be 25%. Is that one fine? So we studied regarding mass percentage. We studied about volume percentage. Next, let us move to another type called as expressing the concentration by mass by volume percentage. Fine. Mass by volume percentage. So mass, how do we represent? We represent mass by W. How do we represent volume? We represent volume by V. You can represent it this way also. Mass by volume percentage. So now, how do you define mass by volume percentage? Mass by volume percentage is defined as the ratio of the mass of the solute. How do you define? It is the ratio of mass of the solute divided by the volume of the solvent multiplied by 100. Okay? So, mass by volume percentage is equal to mass of solute divided by the volume of solvent into 100. You can just consider total volume of the solvent. Okay, fine. Total volume of the solvent or volume of the solvent into 100. We can just do another problem with respect to this one. So, calculate the mass by volume percentage obtained by dissolving 20 grams of glucose in 90 ml of water. This one fine. So calculate the mass by volume percentage obtained by dissolving 20 grams of glucose in 90 ml of water. So we can apply this formula. That is mass by volume percentage is equal to, what is the mass of the solute? Mass of the solute that has been given is how much? 20 grams. 20 divided by, next is volume of the solvent. What is the volume of the solvent that the people have taken? It is 90 ml into 100. So I can just cancel out these two. Fine. Now you people are to tell. So if you just cancel it out, we'll be left with 2 into 100 is 200. 200 divided by 9. So if you just cancel it out, try to cancel it out, 9 2s are 80. So you'll be left with 2. Again another 2. So that goes on written 22.80%. Fine. So 3 ways. One is mass percentage. The other one is mass by volume percentage that we studied now. The other one is volume percentage. 3 types. One is mass percentage, volume percentage, and mass by volume percentage. Okay. Molarity means, molarity it is defined as the number of moles of solute in one liter of solution. This is one point. Defined as the number of moles of solution solute in 1 liter of the solvent. We can just represent it as what? Molarity is equal to number of moles of solute divided by the volume of solution in liters. Okay. We can just try to represent. Anyway, I think you are coming across a term called as moles over here. Hope people try to remember something regarding moles. So we can just write it as number of moles is nothing but mass divided by molecular mass. So in the last class, in one of the last video I told you people, I told I'll be representing the solute with the numerical 2 and solvent with the numerical 1. Okay. Since I'm talking regarding solute, so number of moles means mass of the solute divided by molecular mass. Let me represent number of moles as what? W2. Molecular mass, let me represent it as M2. Okay. So anyway, both will be in grams. So W2 will also be in grams. This will also be in grams. Fine. Now, you can just write the expression as what? Say molarity is equal to W2 by M2 into 1000 by W1. Okay, you people have to pay extra attention over here. So here W1 will be in liters. Okay, W1 will be in liters. Okay. Similarly, we will be studying before one for molarity. Then we can go to one fraction. Okay. So as we studied molarity is what? It is defined as the number of moles of solute in 1 liter of the solid solution. Okay. So I can represent it as what? M is equal to W2 by M into 1000 by W1. Let us try to do a problem with respect to this molarity. 4 grams of NaOH is dissolved in 250 ml of solution. Calculate its molarity. Okay. So now, as we all know the formula, we know the formula is what? M is equal to W2 by M2 into 1000 by W1. Okay. So now, let us consider what is W2. W2 is, as I told you people, it is the mass of the solute. Okay. The mass of the solute is what? 4 grams of NaOH is dissolved in 250 ml. So W2 will be what? 4 grams. Okay. So same way. What is M2? M2 is what? The molecular mass of NaOH. You people can try to find out its molecular mass. The atomic mass of sodium is 23, for oxygen is 16, plus 1 for hydrogen, which is equal to 40. Okay, so M2 will be 40 grams. What is W1? W1 will be 250. Okay, W1 will be 250 ml. So if we just substitute, we can directly get the answer. Say molarity is equal to 4 divided by 40 into 1000 divided by 250. Fine. So 4 tens are 250, 4s are 4 divided by 10 is 0.4. Molar. Fine. It is 0.4 molar. Four tens. Yeah. 10 by 40. 1 second. Will be like this one. 4 by 10, which is 2 by 5. Okay. 0.4. Okay. So now let us try to do another problem. I'll try to write another problem. Find the molarity if 100 ml of methanol CH3OH. So its density being 1 gram per centimeter cube is dissolved in 400 ml of water. Okay, so now you people should go through this problem a bit carefully. Okay? They are given like 100 ml of methanol, density being 1 gram per centimeter cube, is dissolved in 400 ml of water. So if you people remember the definition properly, molarity is number of moles of solute by volume of the solution in liter. Methanol, given that is in ml, is dissolved in 400 ml solvent. So now you people have to find out W1. What is W1? So anyway, you people know the formula, right? So it is M is equal to W2 by M2 into 1000 by W1. So W1 is equal to, what is W1? It is equal to total volume or the volume of solution, which is what? 100 ml plus 400 ml, which is equal to 500 ml. So 500 ml is the volume of the solution. Now you people have to find out W2. So as you people remember, number of moles at mass should be expressed in grams. They have given it in what? ml. So now what you are doing, here you are using another formula by name. I think you must be familiar, all of you. So we know that density is equal to mass by volume. Find density is equal to what? Mass by volume. They have given the density as how much? They have given the density as how much? 1 gram per centimeter is equal to, you people are trying to find out the mass. Let me write it as W2 because we are talking with respect to methanol. W2 will be as it is. And what is the volume we are given? 100. So what will be W? The mass W2 will be equal to, anyway, centimeter cube and ml both just gets cancelled. W2 will be 100 grams. Anyway, you can write it as both remain same. Cm cube or the ml both are same. I think you can just cancel out these two. You will be left with W2 is equal to 100 grams. Now, if you get to know W2, we got W1. Now we want what? M2. What is M2 is equal to? M2 is equal to how much? We have been given CH3 overhead. What is CH3 overhead? Carbon is 12. 12 plus 3 plus 16 plus 1. So what is 12 plus 3? 15. 15 plus 1, 16. 16 plus 16 is 32 grams. Fine. So now can I easily find out knowing all the values? So M is equal to W2 is how much? 100 divided by 32 into 1000 divided by 500. So I will just cancel it out. 500 2s are. I just cancel it out again and be left with what? 100 divided by 16, or it will be 50 divided by 8. If I just try to divide it and try to get the final answer, so 8 6 are 48. We left with 2, so it will be 20. 8 2s are 16, so around 6.2. So that will be the answer. I think we studied 4 different concepts, namely mass percentage, volume percentage, mass by volume percentage, and molarity. Let us go to the next one by name, molality. Molality, it is defined as the number of moles of solute in 1 kg of solvent. Okay, it is defined as the number of moles of solute by the number of moles of solute divided by mass of the solvent solute in kg. So I think it's correct. Defined as the number of moles of solute in 1 kg of the solvent. So this molarity is denoted by small n. So we can write it as m is equal to number of moles of solute divided by mass of solvent in kg. So I think you people should be a bit careful with respect to molarity and molality. Okay, in both the cases you can use the same formula of the type m is equal to, you can use the formula m is equal to W2 by M2 into 1000 by W1. So this will be kg. Okay, either it can be grams or kilograms. Fine. So in the previous one, if you had studied, I think if you have seen, you will be observing with respect to solution. Here it is solvent. When you solve solution in liter, in the earlier case, now it is solvent in kg. Fine. So let us try to do a problem with respect to this one also and try to understand the concepts. Okay. $400 grams of NaOH is dissolved in 1 liter solution whose density is 1.02 gram per centimeter cube. Find its molarity. Okay, so now you people have to find out the molarity of this one. So anyway, I think you people know the formula. Let us try to read both of them. So we know that m is equal to W2 by M2 into 1000 by W1. Here people should remember W1 should be in grams or kilograms. Okay, so now what is W2 they have given? W2 is the mass of the solute. So I have taken 400 grams. Okay, so 400 grams is the mass of the solute. What is the molecular mass of the NaOH? That becomes M2. M2 is equal to how much? 40 grams. So molecular mass of NaOH is how much? 40 grams. Fine. So now I have to find out W1. So here you people should be a bit careful. See here, you want the mass of the solvent in kg or grams. Okay. So I have written 1000 grams. Let me get W1 also in grams only. So what I have got here 1 liter of solution. Okay. I want the mass of solvent, not the solution. You people should be careful. Okay. So here they have given 1 liter of solution. Solution means it is solute plus solvent. Solute plus solvent gives you solution. So the density of that solution is how much? 1.02 gram per centimeter. Let's try to go slowly. So we know that density is equal to mass by volume. Fine. Density is equal to mass by volume. So what is the density? They have given density is 1.02, which is equal to what is the mass? We have to find out the mass only. Mass divided by, so 1 liter means it is equal to how many ml? 1 liter is 1000 centimeter cube. I think you can just try to cancel it out and write here also if you want. I think it will be more comfortable. So 1.02 gram per centimeter cube. So what is that m value will be getting? So m value will be 1000 into 1.02, which is equal to 1020 grams. Okay, so this m will be what? The mass of solution. Okay, I don't want the mass of solution. What do I want? I want the mass of solvent. So how do I find out the solvent? So W1 is equal to mass of solvent, which is equal to, now anyway you people know that you have added 400 grams of solute. Okay, you know what is the total mass of the solution. So the total mass of the solution is 1020 grams. Okay, minus what is the amount of solvent that I have added, solute that I have added? I have added 400 grams. So 400 grams. So 1020 minus 400 will be 620 grams. Okay, so this 620 grams, this becomes the mass of the solute. Mass of the solvent. W1 is mass of the solvent, 620 grams is the mass of solvent. Got W1 is the mass of the solvent, which is equal to the total mass of the solution will be 1020 minus the mass of the solute that you have taken, which is 400 grams, which gives rise to 620. Okay, so now since you know everything, I think you can directly substitute. M is equal to W2 is 400. 400 divided by how much it is? 40 into 1000 divided by 620. So if I just cancel it out, 10 will be there. So 0 cancels. It will be 1000 divided by 62. 1000 divided by 62 means it will be 62 ones are, then you will be left with 38, 380, 16.6 molar. So the answer will be what? 16.6 molar. Our one is mole fraction. So this is again another way of expressing the concentration. How do we define mole fraction? So you can just look over here. Mole fraction, it is defined as the ratio of number of moles of solute. It can be either solute or solvent. Okay, solute or solvent to the total number of moles of solute and solvent. Okay. So in the last class I had told you people regarding how do I represent a solute, how do I represent a solvent. I had told you people I will be representing solute as with the numeral 2 and solvent with the numeral 1. Okay. So here what is it they are given? Mole fraction, it is defined as the ratio of number of moles of solute or solvent to the total number of moles of solute and solvent. Okay, let us just try to understand this one. let N1 is equal to number of moles of solvent. So let N2 is equal to number of moles of solute. So I did try to mention 1 and 2. This one only. I told N1. 1 means we are referring for solvent. 2 means we are trying to refer it as solute. In your textbook, I think they may have also expressed it as A and B. A means solvent, B means solute. So let us stick on to any one of them so that the people don't get confused. So N1 is equal to number of moles of solvent, N2 is equal to the number of moles of solute. Okay. So what is mole fraction? It is defined as I told we can write the mole fraction. We can try to find out the mole fraction for both the solute as well as solvent. Okay. So now let us just try to find out what do we call it as x1. What is meant by x1? X means I told it is mole fraction. Okay. So we try to represent mole fraction by x. So we are trying to represent x means x mole fraction. 1 means I told solvent. Mole fraction of solvent. So mole fraction of solvent and write it as mole fraction of solvent. Fine. Is equal to, now you can see. It is defined as the ratio of number of moles of solute or solvent. What are we talking with respect to? We are talking with respect to solvent. So we will be taking solvent. How do we represent the number of moles of solvent? We will be representing the number of moles of solvent as what? N1 divided by. So what is it they given? Number of moles of solute or solvent to the total number of moles of solute and solvent. Total number of moles means both will be the sum. So it is N1 plus N2. So this is for mole fraction of solvent. Similarly, if you are writing it for solute, X2 is equal to mole fraction of solute. Okay. Solute means if you know how we are trying to represent the number of moles of solute. We are trying to represent the number of moles of solute by N2, which is equal to N2 divided by N1 plus N2. These are the two ways of expressing. So one is the mole fraction of solvent, the other one is mole fraction of solute. Okay. Normally in this chapter we will be dealing with this one. We will be talking most of the times we will be talking with respect to solute because solute means again we are talking how is the solution formed. The solution is formed by the addition of a solute to the solvent. Depending on the amount of solute that is present, the concentration can be there. Okay. For that reason, as we move on proceed, I think you will be getting to know. Okay. So X2 is equal to mole fraction of solute. Kindly try to remember this. Okay. Let us do a problem regarding this mole fraction. Let me take a problem. Say calculate the mole fraction of glucose and water when 18 grams of glucose is dissolved in 180 grams of water. Okay. So first of all, the people should remember we have to find out the number of moles. We haven't been given the number of moles. We have been given grams and both of the kind of things in grams. That is the solute and the solvent have been expressed in grams. So we have to convert that one into solute. Sorry, convert it into number of moles and then we have to calculate. So let me consider. I take N1. N1 is equal to what? It is number of moles of solvent. So solvent here is what? The solvent here is water. So let me take water. Okay. Number of moles of water. So it is equal to what? Again it is, let me write the formula. It is mass divided by molecular mass. Mass is how much? 180 divided by what is the molecular mass of water? molecular mass of water is 18. So 18 divided by 180 is 10. Okay. Similarly, N2 is equal to what? It is number of moles of, we have been given glucose, which is C6H12O6. Okay. Again, it will be mass divided by molecular mass. Okay. What is the mass of solute they have given? The mass of the solute that has been given is 18 grams divided by, what is the molecular mass of glucose? So it is 12 6 72, 72 plus 18, 72 plus 12, 84, then 16 6 So totally again this one also will be 180. Or you can just calculate that, say 6 into 12 plus 12 into 1 plus 6 into 60, which is equal to 180. Fine. So 18 divided by 180 is how much? We get 0.1. Okay. We have found out N1 and N2. Now we have to find out what? X1 and X2. Okay. So X1 is equal to, let us consider. So mole fraction of water is equal to, okay, let me represent it as X1, which is equal to N1 divided by N1 plus N2. What is N1? N1 is 10 divided by 10 plus 0.1. Is nothing but 10 divided by 10.1, which is 0.9900. Fine. What is the mole fraction of water here? It is 0.9900. Same way. If you consider, try to find out the mole fraction of glucose. Is equal to, again, we represent it as H2, which is equal to N2 divided by N1 plus N2. So it is 0.1 divided by 10 plus 0.1, which is nothing but again 0.1 divided by 10.1, which is equal to 0.0099. Fine. The mole fraction of water. So water means this one will be solvent, right? This one is solvent. This one is solvent. Okay. So normally you people will be trying to find out the mole fraction of solvent. Okay.